Hello everyone, welcome back to the show where today we'll be discussing nuclear fusion and nuclear fusion reactors, what they are, when they'll be available, and how they'll affect us. Also, thank you to those of you who tuned in last week for our Dyson Sphere episode. Just to clear up any confusion, it's not a vacuum. So, what is fusion and what are fusion reactors? Basically, fusion is what's called when two subatomic particles are joined or fused together to form a larger particle with more mass and different properties. The fusion side of stars is what created most of the matter in the universe that isn't hydrogen or helium. During the process, a huge amount of energy is released, which is what makes the promise of fusion so exciting to many scientists, as well as those who value our planetary resources and wish for a safer and more renewable source of energy. When completed, a fusion reactor would allow for the collection and relocation of the energy released with the fusion of subatomic particles, in the form of electricity, to power our lives and those of the people around us. In order for fusion to occur under atmospheric pressure, each fusion reactor, no matter the design, would have to reach a minimum temperature of 150 million degrees Celsius in order for the fusion process to commence. That's 10 times hotter than the sun's core. The reason the sun doesn't need to reach 150 million degree mark is due to its intense internal pressure, which lowers the required temperature for fusion. For us humans, reaching 150 million degrees in a fusion reactor is much easier than reproducing the sun's inner pressure. Thus far, every fusion reactor relies entirely on superconducting magnets that make use of the diamagnetic properties of both hydrogen and helium to keep a stream of 150 million degree plasma suspended in space inside the reactor. The magnets are positioned in such a way that the diamagnetic particles, which are repulsed by the created magnetic fields, are forced into a stable and controllable shape inside the reactor. There are several different fusion reactor designs, but the two most prominent ones are the ring or donut-shaped design and the stellarator design. The donut-shaped design confines the plasma in a tube-shaped cavity inside the reactor, shaped like a donut, while the stellarator design keeps the plasma in a straight tube-like cavity that rotates the hydrogen/helium plasma at irregular intervals to cause more collisions between particles. According to Stephen Cowley, director of the UK's largest fusion research centre, fusion may be available sometime in the next 20 years, maybe as early as 2030 for the donut design, although some projects may take longer than others. If and when fusion energy becomes available in the future, many believe that it would usher in an era of near limitless energy and prosperity, where the hydrogen in a glass of seawater could provide as much energy as a barrel of oil with next to no waste at all. Thank you for listening, and see you next week.